Hello students, welcome to the classes. In this session, we will start with the chapter Semiconductors. Before starting with the chapter Semiconductors, let's see few basics. Okay, the atom is made up of three subatomic particles, protons, neutrons and electrons. Right, the protons and neutrons are present inside the nucleus and electrons are revolving around the nucleus. Right, the protons and neutrons are present inside the nucleus and the electrons are revolving around the nucleus in the particular orbits or in the particular shells. Those are called as energy levels. Okay, now the electron cannot revolve in any energy level. Okay, it has some specific condition which is given by the Bohr. Okay, the Bohr model, whatever you are using, that is applicable for what? That is applicable for isolated atom. What is isolated atom? Let's say there are thousands of atoms in a solid. I just take one atom from it, okay, and near to that atom, whatever I have taken, there is no other atom. It means it's completely empty. Okay, such atom, okay, is called as isolated atom. So whatever the laws we have derived, those are applicable for isolated atoms, right? So in that, what I mean is, in isolated atom, the energy levels, whatever the conditions we have given, the energy levels are discrete. It means if there is some nucleus, let's say there is some nucleus here, okay, the electron, okay, revolve around the nucleus only in a particular orbit or particular shell at a particular distance, okay, and one more electron may be revolving around the nucleus in one more orbit or one more energy level, okay, but one more electron if I take, it cannot revolve around the nucleus between these two levels. So these are called as discrete levels. They are not continuous. The levels are discrete. They have some distance between them. They have some energy difference between them. Those are called as what? Discrete levels. Now what happens if I bring one more atom? Okay, let's say I'll bring one more atom. Okay, now you can see here the electron, okay, the electrons in this atom, let's say this is second atom, let's say this is first atom. Now what may happen, okay, if I bring the second atom nearer to the first atom? See, we know nucleus is positively charged and the electrons in this atom are negatively charged. So here electron is negatively charged. Here nucleus is what? Positively charged. So when I bring one atom nearer to another atom, so these electrons may be attracted by this nucleus or these electrons are repelled by these electrons. So attractions and repulsions will happen when I bring two nuclei or two atoms together. Attractions and repulsions will happen when I bring two atoms together. Okay, it means there is an interaction between two atoms. So because of this interaction, this electron may change its path. It may come inside or it may go outside to a little extent. It means this energy level has splitted. It has been splitted. It may come inside or it may go outside. It means what? There may be some another energy level inside or there may be some another energy level outside, right? There is a little variation in the energy levels in case of what? Solids. Why? In solids, atoms are very close to each other. Because of that, there is a interatomic interactions. It means interactions between the two atoms will happen. Because of this interaction, the discrete energy levels will split. Okay, now let's do one thing. Let's consider the energy levels in the form of straight lines. So why we consider in the form of straight lines is it becomes easier for what? Prediction and to draw. Okay, so let me consider the energy levels what in the form of straight lines. Okay, so let's say I have an atom, okay, and let's say this is its energy level. Okay, electron is revolving or electron is having particular energy. When I bring one more atom, okay, this energy level may split, right? If I bring more number of atoms together, I mean in solids, for a particular atom, okay, if I take an example of solid, okay, if this is an atom in solids, it is what covered by many other atoms, right? It is surrounded by many other atoms. So because of that, this atom, I mean whatever the energy levels are associated with this atom, they will split. Okay, they will split into many energy levels. Okay, and those energy levels are closely packed. It means the energy difference between the each level is very small. For example, this energy level, if I mean let's consider this is the energy level of this atom when it is isolated. Okay, now when these atoms come together, what happens is this energy level will split to form closely packed energy levels. Closely packed energy levels. Okay, so it's almost the energy levels are almost continuous. It means it almost looks like what? It looks like a band. Okay, the energy levels are so closely packed that we cannot distinguish. Okay, we cannot distinguish. There is no much distinction, okay, between the energy levels. Okay, it looks like what? Continuous form. Okay, it's not actually continuous, it is discrete in nature only, but as the energy levels are so closely packed, it almost looks like what? Continuous. Now this continuous, I mean which is looking like continuous, right? This band we call it as energy band. We call it as what? Energy band. Okay, now in energy band there are again different types. Okay, so for every energy level in an atom, for every energy level in an atom, there is an energy band. Okay, so what is meant by valence shell then? We know valence shell, right? What is valence shell? The outermost shell which is partially or completely occupied in the atom. The outermost shell which is partially or completely occupied in the atom is called as valence shell, right? Now the energy band associated with that level, it means if the valence shell splits to form energy band, that band we call it as what? Valence band. Okay, valence band is nothing but what? Energy band associated with the what? Valence band is what? It is an energy band. Energy band associated with, energy band associated with what? It is an energy band associated with valence shell. Okay, so valence band is nothing but energy band associated with valence shell. Okay, now what is above the valence band? What is above valence shell? Above valence shell there is no other shell, because that's the highest and highest energy shell which is occupied by electrons. It means above the valence shell, that is there is no other shell. It means it is empty. It means it is empty, right? Now if the electron is present in the valence shell, it means what? If the electron is present in the valence shell, it is bonded with the atom, right? Because that valence shell, or let's consider valence band now. Okay, if the electron is present in the valence band, it is associated with the atom. Now let's consider, okay, this is my valence band. Okay, let's consider this is my valence band. If my electron is present inside this valence band, it means this electron is bounded to atom, right? Because that's the energy level of an atom. So if electron is present inside valence band, it means it is associated with the atom. Now what happens if I supply some energy to this electron? What happens if I supply energy to this electron? If I supply energy to this electron, if I supply sufficient energy, this electron which is bounded to atom, okay, gets energy, and it gets, it comes out of the energy of, it comes out of the atom system. Okay, it comes out, it becomes free now. If I supply energy, as nucleus was what attracting it, okay, now if I supply sufficient energy, this electron will what it will do, it will just come out of the atomic system. There, if it is coming out of the atomic system, it means what, it is coming into the empty space, because that was what I told, the valence band, the electron which was present in the valence band, that was like the outermost electrons, right? Those are nothing but outermost electrons. If they are coming out, it means there is no other shell outside. It means what, they are becoming free, they are coming into the empty space. That empty space, here we refer it as what, conduction band. That empty space we refer it as what, conduction band. So what is meant by conduction band then? See, obviously conduction band is also, we can consider it like what, it is above valence band, right? Because electron has to come out of it. So conduction band is like the one more energy band, let's consider. Okay, that whole empty space above the atom, whatever we have, let's consider it as energy band also. It is above valence band, but it has higher energy compared to valence band. Why it has higher energy compared to valence band? Because if the electron has to go from valence band and if it has to become free, I need to supply energy. It means what, the electron has less energy in valence band. If I supply energy to it, it goes into the conduction band. It means conduction band has more energy compared to valence band. Okay, now when the electron has jumped, okay, let's do one thing. Let's consider a conduction band. Let me write as CB for conduction band. Okay, now when the electron, when I supply energy to this, okay, the electron jumps from valence band to what, conduction band. Now you can see a place is left empty here. A place is empty here because this place was occupied by earlier by what, the electron, but now the electron is jumping from valence band to conduction band. Jumping from valence band to conduction band is like becoming free. Okay, let's do one thing. Let us consider a football surface. Okay, let's consider this is your football surface. Okay, now let's consider an electron is present in the football surface. Okay, so let's consider a sphere, a small sphere which is placed on the football surface. Now if I shake that sphere, what happens? If I shake that football surface, what happens? The small sphere present on the football surface falls down, right? Let's consider a football surface. On the football surface I am keeping a small sphere. If I shake that football surface, what happens? The electron will falls down, right? Now that electron or that small sphere is like electron. Okay, that small sphere is now free to move everywhere, right? So it's like a free electron. Okay, it can move anywhere. The electrons or the charge carriers which will move, they will conduct electricity. The electrons which will move in a particular direction or in the same direction, okay, they conduct electricity. They are responsible for what? They are responsible for conduction of electricity. Okay, now as these electrons have become free, see, the electrons are present inside conduction band. It doesn't mean that they are associated with atom now. Okay, they have come out, they are free now. Okay, they have come out, they are free now. Okay, so if they are free, it means they can move. If they can move, they can conduct electricity. That's why it is called as conduction band. Okay, now I told the electron has to jump from valence band to conduction band. I need to supply this energy, right? But how much energy do I need to supply? So based on that, the solids are classified into three categories. Metals, or let's say metals are generally nothing but conductors. Solids are classified into three categories: conductors, insulators, and semiconductors. Okay, based on what? Based on the energy difference or energy I need to supply, based on how much energy I need to supply to this electron so that this electron jumps from valence band to conduction band. Okay, one more thing. That energy difference, whatever I need to supply, that is called as energy gap. This is called as what? Energy gap. Now here you can see what is a band I told. Band is nothing but what? Group of levels, right? So if I take group of levels here, let's take group of levels here. Okay, so let's take group of levels here. Now here you can see this energy gap is nothing but energy difference between what? Between this level, the topmost level in valence band and bottommost level in conduction band. It means what is energy gap? This is energy difference between the highest energy level in valence band and lowest energy level in conduction band. That is called as energy gap. Okay, so based on energy gap, solids are classified into three categories: conductors, insulators, and semiconductors. Okay, now before going to the next concept, let's see. I told you what, when the electron jumps from what valence band to conduction band, it leaves a empty space here. This space is empty now, right? Now this empty space we call it as hole. This empty space we call it as hole. Hole is nothing but what? Absence of electrons. Okay, now remember, in conduction band we have free electrons, not just electrons, they are free electrons, they can move anywhere. In valence band we have holes. Okay, so in the next session we will see the classification of solids based on energy gap.